If you haven't already, please sign in because pizza is not free. Is it, Brandon? It's not, right?
It's not.
It's not free.
It's costing
Costing about $200 this time around, right? 200? 200? Two Benjis? For those of you on the live stream, welcome. And yeah, shall we go ahead and get started? Yeah. Y'all want to come up here? Yeah. I'm stepping on your shit. Here, I'm gonna move. You get closer.
You don't want to be the Hack Night organizer?
No. In fact, here, I don't even want to talk.
No, please.
Hello. Hi, y'all. I'm Chris. I'm with the IEEE student branch.
I'm Meg. I'm one of the co-presidents of Women in Computing.
I'm Lily. I'm a co-president of Spark.
I'm Brandon. I'm also a co-president of Spark.
You know, Brandon can just keep the mic. He's the presenter today. Doing intro to web security stuff. I'm gonna give him a sick introduction real quick. Brandon here. I'm fucking with you, man. All right, everybody. Here's Brandon.
I'm pissed off. How's everyone today? Good. How's the quarter going? Okay. I'm Brandon. I'm a Sagittarius. Really? Cool. So this is an intro to web security. So a few caveats. Firstly, this is not meant to be like a comprehensive tutorial on web security in its entirety. This is meant to go over a couple of web application vulnerabilities in detail and briefly cover some of the concepts you would need to know to understand them. So my goal for tonight is to get you to recognize and become more conscientious of these vulnerabilities in both your applications and other applications on the web. So this presentation is truncated a little bit to save time and also to have you guys work sort of independently on your own like hacking exercises later tonight. But after this talk, for people here and like people on the stream, I'll post the full slides, untruncated slides, as well as a more like comprehensive guide on not only the vulnerabilities we talk about tonight, but more topics in information security that I feel are important. And yeah, and finally, of course, if you have questions that are like directly related to the material, please stop me and ask them, and like hopefully I'll be able to answer them. If it's not related, feel free to come talk to me after this. Cool. Are we good with that? Okay. So this is basically what we're going to go over so far. We have some definitional stuff, some concepts that you would need to know to actually understand some of the vulnerabilities. And some of those concepts are some basic networking concepts, some about web architecture, and a really brief SQL overview. Okay, so who here has ever programmed for the web? Okay, that didn't help me at all. Okay, who here has worked with a database? Okay, cool. Thank you for participating. So firstly, web security is a child of information security, or InfoSec. So information security, as like the name suggests, is like the practice of protecting information or data from unauthorized access, modification, or destruction. So this is a very formal definition, right? So like what you need to know, it's really just the practice of just protecting your data. It's purposely vague, and it encompasses various fields like internet security, network security, mobile security. But like the main underlying concepts of information security is first is confidentiality, which basically means that all persons who are meant to get access to the resource or information, confidentiality is the persons who are not meant to get access to the information don't. And conversely, another thing is availability, meaning that the persons who actually have permission to that sort of resource actually do have access to it. And lastly, another key component is integrity, which is just maintaining the sort of purity of like the data or information that you're meant to protect. So yeah, so web security, like I said, is sort of like child branch of information security, and it's basically operates in its own sort of like web ecosystem, and there are two parts to that ecosystem. One of the sides is a web browser, which is basically it's basically like, you could think of it as sort of like a vehicle to travel to different destinations across the internet. And the second is like the actual web application code. And that's like the actual code that an engineer develops and hosts on a server. So web browsers are prone to persistent bugs that are sort of like malware and can affect other users. Examples of this are like keyloggers or like botnets. We're gonna focus on like the second, which is actual like application code, which are prone to like vulnerabilities mostly caused by bugs that developers make when they develop sites. So yeah, this is like the typical web architecture. There exists like multiple clients to a server or multiple web servers that contains a hosted web application. And that web application makes what are called HTTP requests. And HTTP, it stands for Hypertext Transfer Protocol. It's basically like a application layer protocol for transferring data over the web. And what I mean by like application layer, that's basically with respect to the OSI model. And the OSI model, which is the Open System Intercommunication model, is it's a model that like characterizes the layers of abstraction to describe how hosts in a network communicate with each other. So as you can see, the application layer is like the topmost layer of this OSI model, meaning it's the most abstract layer. And HTTP is like the canonical interface that computers use to communicate over the web and send data over the web. So for example, if I am client 1 over there, and I'm trying to access facebook.com on my computer, I would go onto facebook.com, and my web client operating on my web browser would make an HTTP request to request HTML from the web server. Also, if I want to like load like other important data, like my posts or like my friends' posts, it would query like the important information from what is a database server, which hosts an actual database that contains the data you want, and it sends it back to the client to populate the web page. Does that make sense? Okay. Okay, why is web security important? There's a lot of the reasons why it's important, and I think it should make sense for a lot of people. So basically, what's important, or why it's important, is that like security vulnerabilities cost you and your company like lots of money. Large-scale web applications, like including like bank applications, like e-commerce sites, social media sites, like all handle large amounts of data, and they have like a huge incentive to actually keep that data secure. But even with this incentive, many companies are still vulnerable to like a lot of these security attacks because bugs exist, like bugs in code exist. And they'll probably continue to exist because, well, as long as like humans are there to code them, bugs will continue to exist because humans, as you know, are like inherently flawed creatures. Yeah, so like even with this incentive, this continues to happen with like very large companies. If you remember in 2013, there was a SQL injection attack that really costed Yahoo a bunch of money in that they lost a bunch of passwords for like 500,000 users, and those passwords were all stored in plain text. So whoever had them had access to their accounts, which is like not very smart. And that recent like Equifax thing was also caused by very avoidable human error. So web security is important as long as this is an issue, and we should be vigilant of these sorts of vulnerabilities. Okay. Okay, wait, is what I said so far, does that make sense? Okay, cool. So this is a list, as you can see. This is a list curated by OWASP. And what OWASP is, it stands for the Open Web Application Security Project. And it's basically an organization that is dedicated to improving the security on the web. And each year they create a top 10 list of like the most common or most popular vulnerabilities that exist on the web. Here's a list of them. Here's what we'll hopefully get to today, which are 3 of them. And the top one, SQL injection, happens to be the most common, even though it's probably the most simplest out of all these 10, which is weird. Fun fact. So yeah, before we talk about the first vulnerability, which is SQL injection, we have to know a little bit about how SQL databases work. Who has worked with a SQL database? Oh, dude, we got some hackers in here, man. So yeah, SQL is a query language that allows for like the manipulation of data or like data retrieval from a relational database. So if you're wondering what a relational database is, it's called a relational database is because it is an entity that is comprised of actually a bunch of tables, which a bunch of rows or tuples. With attributes that can relate to one another. So you have a big network of tables, and they all have like theoretical pointers to one another to make relations. And that's what sort of makes it useful, because when you form like all these relations between tables, you kind of avoid a sort of like redundancy in data. So SQL is actually made up of like 2 different components. One is called the Data Definition Language, or DDL, and the other is called the Data Manipulation Language, DML. The first one is a language that creates or alters or like deletes tables. They're basically the language, the part of the language that actually modifies tables. The second one is a language that modifies the tuples within those tables. Okay, any questions so far? No, it's fine. Okay, cool. So let's just say I have this table. It's like a bunch of courses. So I have a table called course. It has a course ID, department, course number, course name, and its professor. So you can see at the top, that is the schema of the table. And now a schema is basically a definition for a table. It basically has like the table name, and within it, it's just like a list of its attributes. And you're gonna see that course ID is actually underlined. And that is because course ID is gonna be the primary key for the table. It's basically like a primary identifier, which helps distinguish one tuple from another. Does that make sense? Cool. So yeah, for the purposes of SQL injection, we're not going to really go into destroying data or modifying data or destroying tables or modifying tables. All we need to know how to do is work with existing data. And how we work with existing data in data retrieval is through query statements. Now, this is sort of the predicates or expressions you need to form like a canonical like query statement. It uses a select statement, which has a list of attributes. It's basically like the attributes you're interested in, or the columns you want the output to have. A from statement, it's asking, or a from expression, and after that follows like one or more tables. That's basically the tables that you're interested in and that you're going to work with. And like a where clause, which asks for a condition, and we'll get into that right now. So this is a sort of a more realistic scenario of how querying data will look like. We have like our original table. which like consists of like all the attributes we've seen. And so we have a query statement, select star, which means select all columns, from course where department equals eeks. So we're really getting all the rows where like the column department is equal to eeks. So what that's going to reduce down to is the output of this table, or this output rather, where it includes all of the columns that exist, and it includes all the rows that have department equals to eeks. Yeah. Yeah, you could also, this is an example of, it's like basically the same query statement, but we project different columns. So in a case where we're only interested in a course ID, a department, and a course number, it would only project those types of columns. Cool. So, oh my God, my tables are so shitty. Okay. I feel like in a more realistic case, you're not going to really have a table like that on the left, because I want to say a good organization of a SQL database, or SQL tables rather, try to reduce redundancy as much as possible. So we have a lot of pointers. So what I mean by that is, like, let's just say we have a table of course again with course ID, course number, the course name, and a department ID. And so like this department ID is going to refer to a role, is going to be a foreign key, which is basically like a pointer or a reference to a different table. And in this case, it's going to be the table called department that has a department ID as a primary key, and also has a department name and a college that it belongs to. So as you can see, if you query it, both tables in a correct manner, you'd still get the same information as we did in the previous query. And I'll show you how to do that right now. So the query is select all the things we're interested in. Let's just say course number, department name, and college. We, this time, are interested in 2 tables, and we're only interested in the rows that have a corresponding department ID in courses. So we're going to get this sort of output. Oh, no, never mind. I'm just kidding. This is a secondary way to do the same thing. It uses different syntax. It uses a clause called inner join. So this time we only have inner from clause. We only refer to course, but we say join on department on department ID, and it should output the same thing. What is this? Does this make sense? Cool. This is a comic in very Fabian fashion. Yeah, you could read it, or you could just read it later. It's fine. So we're going to talk about SQL injection. So what is SQL injection? SQL injection, as it says, is a malicious injection attack that occurs when a user sends specially crafted input to cause a web application to do something it doesn't really want to do. And so it's a very common attack, especially with like login systems. And it exposes the flaw of, that's a grammar mistake, implementing dynamic SQL queries. So there's nothing inherently wrong with dynamic SQL queries. And what I mean by dynamic SQL queries is like sort of concatenation of SQL statement. Does everyone know what I mean by that? If not, okay. Yellow markers. Oh, hell yeah. Okay, yeah. Okay, can everyone see this? No? Or is it going to be bad? Okay. So let's just say there's like a login system. right? And it takes a username and a password, right? And so like, I guess like a typical way to like actually find out if the user exists when given a username and a password is to like query for it, right? A query for it with the conditions of username equal to the user given username and password equal to the user given password, right? So like that statement would look a little bit like this. Let's say we have a table called users. We're gonna select all from users where, and I'm gonna wrap around a little bit. Username equals, this is the username that the user gives us, and password equals the password that the user gives us. Right, so that's what I mean by concatenation, because really this is just a string, and we're just concatenating what the user gives us into the SQL statement and then executing it. And now there's nothing inherently wrong with this, although it's sort of bad practice. But what's wrong with it with dynamic SQL queries that are just executed on runtime is that we aren't really validating this input at all, which is bad. So it could be, you could put anything in there. And so that gives way to like a vulnerability for a SQL injection. And I'm gonna give a demo in a little bit, and I'm gonna show you how SQL injections could be like really bad. And yeah, that's something, oh yeah, that was a slide. Okay, yeah, just look at that. Okay. But yeah, this is basically the same thing, but just like in with an example of Chris Chen and his like shitty password. Yeah. Is everyone good reading with that? Okay. Okay, yeah. So this is the sort of vulnerability I'm talking about. So we have the statement, which is a string, right? And so like this is a malicious case in which it's the user is like deliberately trying to attack or hack into the login system. So instead of a password, it enters this. And so like the SQL statement now evaluates to this. Can anyone tell me why this is bad? Yeah, yeah. So like what it's doing, that's completely correct. So what it's doing is, what it's doing is since it passed in a single quotation, this SQL statement terminates early. And now it gets that SQL statement now that it's ended and says or 1 equals 1, which is always going to be true. And then it ends that statement and then uses dash dash. And dash dash means it basically tells the database ignore whatever it is on the right of that statement. So really we could ignore whatever is here and just get that statement, which is always going to be true. And meaning the hacker got into the data, into the actual site, logged in as a user. Oh my god, please don't. Okay. Okay, so does that make sense? Okay. So yeah, what happens when you suffer a SQL injection? We sort of went over this. This exposure of sensitive information. You might lose data. You saw with Yahoo, it exposed like a lot of like user accounts with passwords stored in plain text, and like that's always bad. And in a lot of cases, a SQL injection could actually like drop tables in your database, which is actually like the worst case possible because then your website doesn't even function at all. So yeah, it's like really simple, but it's like really disastrous. Yeah, so SQL injections are really common because everyone uses SQL databases. It's become sort of like the standard of like really large scale enterprise companies to use SQL relational databases. So like that's the first thing, the ubiquity of SQL databases. Basically, poor implementation on the developer's part. And the last part is sort of a weird thing, but it's pretty true. That it's something OWASP always mentions. It's really like the attractiveness of the target. Like no one would really, there are gonna be fewer hackers that are trying to hack like some database that you like built like on your weekend. Like if you're a large company, that data is just more attractive because you have like much more data on much more users. So yeah. And now I'm going to show you a SQL demo of something I made. Does that work? Oh my god, okay. Oh. Okay, so imagine this is Caesar. So this is made in PHP. But it's really vulnerable to attacks, especially SQL injection. Oh, fuck. Okay, yeah. Does that work? Okay. So yeah, it has. I'll actually show you. Oh, you're not supposed to see that. Is that big enough? A little more. Okay. So basically what we're operating on, these are the sort of tables I have to make the pseudo Caesar. We could look into these. First one is courses. We've seen this before. They have a department ID and a professor ID, which reference the foreign tables, professors. Let's see, professors. Oh shit. I mean, oh darn. Yeah, professors have a professor name and a department ID. And what's the department's called? Oh. And departments just have a department name. But what we're gonna work with right now is like the authentication system. And this is what a user schema looks like. It has an ID, a username, and a password. So I want to sort of like log in. So I'm gonna type in my username, which is I cannot read. My password is please help me. And it's not, you know, they usually hide the password. Applications usually hide passwords, but I'm going to show you it to show the vulnerability. So I'm logged in as I cannot read, and this is the query it shows me. It's kind of the query we constructed there, and this is fine because in the most benign case, this SQL statement is actually going to work. But if a user is a little bit more cunning, you can kind of see the vulnerability in, I'm going to do the thing we just talked about. Okay, so I'm inputting this as my password, and it's going to kind of take advantage of the manipulation of like single quotations, and it's going to terminate that SQL statement early, use the OR clause, and going to end with this, which is going to be always true. Start quotation 1, end quotation is going to be equal to start quotation 1, end quotation. So yeah, as you can see the SQL statement here. Terminate early, or 1 equals to 1, and I'm logged in as I cannot read. So does that make sense? Cool. So the problem with this is basically this problem we described. We have sprint, which is basically storing these variables in. We do no validation of the username or password. Okay. Now I will go to a vulnerable search. Now, this is basically a database of just a bunch of like course names. You could see the department, the course name, and the professor that's going to be teaching that course. Basically, it does like an OR search, meaning like it satisfies all the rows that have this department name or this professor name. So if I do like Sarah Sood here, this comes up, and I would do like all courses. This is the courses I have in the database right now. So if you could see this like SQL query that's being executed, I'm doing a projection of the columns department name, the course name, and the professor name on courses. And I'm performing a join on departments on the department ID. I'm doing a join on professors on the professor ID, where department name is an empty string or the professor name is Sarah Sood. Does that all make sense? Cool. Now I need to introduce another SQL clause that I haven't introduced before, and that is union. And what union does, it gets one SQL statement and combines it to a second SQL statement and just returns the output. So I'm gonna just like do the sort of hack right now, and then I'll talk about it a little after. So the hack is right here. I saved it because I'm lazy. And I'm gonna put this in the professor name. And so what I'm doing is I'm terminating the previous SQL statement. I'm doing union with another statement that's gonna follow it, which is select all from users where 1 equals to 1. And so that's just gonna print out all the users. The one thing, I guess like the one condition is that the users table has the same number of columns as the table in the previous statement. And so like in this case, yeah, like coincidentally, they both have 3 columns. So like this hack is actually gonna work. And so here are actually all the users printed out with passwords like in plain text like Yahoo.
Why is the password called name professor?
Where?
Oh, yeah, I see, because
Yeah. This is all front end stuff, so it doesn't correspond to the database at all. So yeah. What do you want to see? Yeah, I just want to see my password. You have the shittiest password. This is literally like Microsoft Windows default password. Okay. So yeah, here's sort of my code here, and you kind of see like the same problems there was last time. Here is the sort of concatenation of the statement, and here we're storing department name and professor name without any sort of validation at all. Yeah, so that's like SQL injection. You kind of see how that's pretty detrimental to a company's site. Now we're gonna see like how to prevent it. Let's see if I can work this. Oh my god. Okay, thank God. Okay, so how do we protect web applications from SQL injection? There are a number of ways. One way is to stop using dynamic queries, like we talked about before. Another way is, to use parameterized statements. And what I mean by that is, what I mean by that is that there are certain language-specific interfaces in which you could instantiate what's called a parameterized statement or a prepared statement. And the benefit of that is that it pre-compiles the SQL statement, and then you just supply it with arguments. So in this next case, wait, Chris, can you help me with this real quick? Here's a technical difficulty. Oh my God. Okay, hold on.
What are you talking about?
Jesus Christ. What are you doing? Okay, thank God. Okay, never mind.
Wait, you're alright?
Yeah. Okay, that's fine, it's fine.
Hey man, you want to like speak a little bit more into the microphone there? People, you know, might
Oh,
be
yeah.
watching the live stream that can't.
Oh my God, sorry. Yeah, I'm sorry for everyone in the live stream. I've just like disrespected you. So yeah, like I was saying, it pre-compiles the SQL statement so it doesn't evaluate at runtime. So the importance of that is that it actually has something to check the validity of the arguments you pass into the SQL statement. And we could see an example here. Here, this is an example in Java. I'm sorry. But again, the first line, you could see we're getting the parameter of username. And then we have like a string query, just like last time. But instead of concatenating username right onto that, we just put a question mark. And that's going to be really like a placeholder. And something like a place where we're actually going to put username later. So we pass our string query into our prepared statement, and then later set the string, one meaning the first argument, in as username. So it's actually putting this here. So as this pre-compiles, it's going to check the argument, check if it's valid, check if it has any dangerous characters, and then it's going to execute it. So it's just much safer than evaluating at runtime. Does that make sense? Okay. This is an example in PHP. Again, I'm sorry. But yeah, it does the same thing. It has a method called prepare, and once to actually execute, you need to pass in an array of values that correspond to the markers you leave there. So yeah, the second solution is escaping or sanitizing inputs. Now, like, what does that mean? So escaping inputs means that when a user sends you data, let's just say it's like a string of characters, and you need that data to perform some kind of SQL query to your database. Before you do that, you want to convert that string in a way that encodes potentially dangerous characters into escaped characters. And so what that does is, like, right here, that's a pretty problematic statement, I would say, without escaping characters. But the second one, it actually escapes them, meaning that it puts an escape character behind that, which is just a backslash. So when the database actually like evaluates it, it's just going to look at it like a regular character, not like something that's going to be pertinent to like the evaluation of the SQL query. Cool. Rad. Yeah. So last thing is sanitizing inputs. On the client side, you can sanitize your inputs, which basically means like check beforehand before you execute the query if even the user generated like input is like valid or like the input that you actually want. So an example of this is like, let's just say like emails. So like if you have a query that depends on emails, before you actually send that or query off or execute that query, you're going to actually check if the input you're given is a valid email. And one way you could do that is regular expressions. And if you haven't heard of what a regular expression is, it basically means, or it allows you to define a pattern of a certain form. And in this case, it would be like a form of an email. And you say, send the query for all the inputs that look like this. Otherwise, reject it. So in the most obvious case of an email, it would have an @ sign. It would have like a .edu email address or something. But yeah, that's one way. Another way is to trim white space. Yeah, that's sort of like an arbitrary one. And just plainly or generally rejecting inputs with invalid characters, just however you see fit. So we're gonna kind of see an example of escaping And the same thing. Oh no. Okay, now let's go to the same example for a login, but we're gonna go to a secure example. So the main difference between this code and last code is we use sort of like a function that's inherent to MySQLi, which is a SQL driver for PHP. And it is a real escape string. So it's going to escape all the danger or potentially dangerous characters in the SQL query for you. So we do that before passing it into this SQL string, and then we evaluate it. So we could try the same thing as last time. And it says wrong username password combination. And why that is, if we look at the query statement, this isn't true anymore because it uses escape characters and they aren't true. Like it isn't like the one on the left, the operand on the left is not equal to the operand on the right, as you can see. And we can see this in like the other example too of a secure sort of thing. We do the same SQL query and it doesn't print out anything. It just fails. And the same just happens here where this statement or this clause isn't true. Yeah. Okay. So other considerations to make when developing a secure web application is maybe even considering using some kind of secure authentication service that you know will work instead of like implementing everything by yourself. One is OAuth, which is like an open protocol authentication service that basically like implements authentication for you and just gives you like a series of endpoints that you could or functions that you could use to implement authentication. So that leaves just like a smaller margin of error for this sort of attack. It can even like connect you to like third-party sites like Facebook, like Twitter, GitHub, and things like that. Another thing is it's not like directly related to like the SQL injection attack, but I mean, if you are gonna get attacked with a SQL injection, you better have your passwords hashed. Learn from Yahoo's mistake. Use some sort of like hashing algorithm to protect your users' passwords. Yeah, and the last one is the principle of least privilege, which is also like tangentially related because it's basically the idea that users should just have the minimum amount of privilege to grant the user the functionality it needs. So, for example, you're not going to give like an average user like admin access to like see all your data. Like that would just be unwise. So yeah, any questions on this before I go to another vulnerability? Yeah, you're going to use some sort of like encryption algorithm to do that. And then I typed out like a more comprehensive guide that's supposed to pair with this sort of presentation. So it's actually gonna list out a bunch of like popular like encryption algorithms for you. Cool. So the next one is cross-site scripting. And it's basically another vulnerability that actually injects JavaScript code into your web page. So it exploits how web pages like evaluate user inputs. If they aren't validating the user inputs, maybe it could evaluate HTML or JavaScript, which is sort of like a big no-no for that. I'll tell you why this is like potentially risky. But first, let me talk about the different kinds of like cross-site scripting. The first one is non-persistent cross-site scripting, and it's basically the most popular or the most basic one. It's basically you inject some JavaScript code into a web page. It does some kind of effect. Maybe it steals your all your users' cookies or something, or it prints something out to all your users. But it doesn't persist like forever. So let's just say if I were to inject like some code into Facebook and just to say hi to all my users or all of like Facebook's billions of users, then that doesn't actually persist on like to the next day. Whereas like a persistent cross-site script actually persists. And I'll give you an example. There was something on MySpace. If you guys remember MySpace. There was like a worm going around. And basically a guy posted, he basically made a post on MySpace. And I guess they weren't validating their inputs that well. So hidden in the post was actually a script tag with a bunch of JavaScript code in it. And what the JavaScript code did was like made a person that viewed his profile add him on MySpace, and also sent like the script to all of their friends so they could add them on MySpace. So like what's very like dangerous about this is that if your HTML or if your browser even loads the document that contains a script, it automatically evaluates it. So if it's persistent, like a post on the web, which is actually stored in the database and will persist for a number of days until it's deleted, anyone who looks at that post is going to be vulnerable to whatever is contained in that script. And the last one is self cross-site scripting. And so that's basically depends on social engineering to trick someone into actually injecting malicious JavaScript scripts into their own browser. And it's actually, you may think, oh, this is like really stupid, like why would anyone do that, right? But it's actually like more common than you think. So common that like if you look at Facebook's like page and you open up like inspect element, it actually like gives a warning not to put JavaScript that was given by someone else into the browser, because people actually do it. Yeah, so social engineering is wild. It's like a wild concept. It's basically sort of like a psychological manipulation or deception to kind of trick another person into like giving up really sensitive data. It's very cool, but also like very dangerous. So yeah, we kind of talked about this. What you could suffer, the spread of worms, like in the case of MySpace. Session hijacking, they could steal your cookies and actually impersonate you on the website. Denial of service attacks, if the script runs and it's actually, let's just say, a loop that like posts a bunch of pop-ups or like makes a bunch of requests to the database, it might just like drop the server, and then it will be like a denial of service, like no one else will get access to that service. And yeah, a general just threat of sensitive information. So yeah, if people could go here right now to this link, I'm gonna show you an example of like cross-site scripting. Let me know. Everyone just like sign in on a team. It doesn't matter what team you're on, but I'm just gonna do a little experiment. Oh my God, Vinny. Okay. Okay, yeah, that's enough. I mean, if you guys wanna keep on going on there, it's fine. Okay, cool. Oh my God, I'm Spy Master. Oh my God, this is bad. Okay, let me. Okay, wait. Okay. Oh, I need one more person on the blue team, or someone switch teams. Okay, okay, I'll go. Yo, Lily, what's happening? Okay. Oh my god. Is anyone not Spy Master? That I could use, huh? Make your names. Oh, is that how it works? Okay, let's try this one more time. It's done alphabetically. Okay. Let's start this. I'm sorry, guys. Okay. I'm gonna start. What? Yeah. Okay, thank fucking God. Okay, we can finally continue here. Okay. Okay, so now that we're in here, oh my God. Okay, I'm gonna inspect element and check the sources on here. And what I'm gonna do is take advantage of unsanitized input. And so you could see here in the function add message. I don't know if you could see this very well. Can you guys see this? Okay, in this function add message, it has a message which is the content of this message box, and it stores it as raw HTML without actually validating it, and it actually evaluates. So really, we could actually put any type of HTML or inject any type of HTML into this. So for example, if I make a script tag, and a script tag, for those of you who don't know, is an HTML tag that basically evaluates any JavaScript that's in it. So if I do make an alert saying, hey, it's me, Brandon. Did any of you guys get it? Or did my thing not even show up?
That's what's happening.
This is a botch. Okay. What's supposed to happen? Okay. What's supposed to happen is I inject the script tag. It evaluates my JavaScript, which has an alert. And because that HTML shows for all users, it's in everyone's HTML document. So because it's in everyone's HTML document, it evaluates that JavaScript for every user. So how this could be potentially dangerous is if it's like not a benign script like that. What if, for example, I'm just gonna do this here. I wrote something like this that actually took advantage of your browser. And one way I could take advantage of your browser is using the window.location property, which basically is like a URL of what your browser is pointing to. So if I can evaluate any script I want, I could change your browser's location if I wanted to. And that could be potentially malicious. So let's just say I go to a site called Cookie Stealer. And in that, I send a query parameter of cookie. And then I insert or concatenate a document.cookie. And let's just say this website relies on document.cookie, which is sort of like, you can think of it as a string that's supposed to represent a key value store. A lot of sites actually rely on that for authentication. Like usernames are stored there, passwords, IDs, or anything that they need for login is actually stored there. So if I go here and this script at cookiestealer.php gets whatever is passed into cookie, then I could just have a script that just constantly stores everyone's cookies, and I could actually impersonate you on this site. So I could just have a huge laundry list of usernames and their cookies. So you can see how that could be bad. Because, I mean, if I have access to your account, then you're basically pretty much fucked. I have all your data. So yeah, that didn't work out too well, that demo. But I mean, it's fine. But does everyone understand that? Or sort of the threat of that? Cool. I'm gonna go back. Okay, so prevention, this vulnerability is like very similar to the SQL injection, and the preventative members are actually very similar as well. One thing you need to do is like sanitize your HTML always, especially if you're injecting it into your HTML document, and especially if it's going to show for all users. So like there are various methods across languages, especially JavaScript, because that is a browser-specific language, to actually sanitize the HTMLs for you. And what that would do is actually sort of not escape, but encode some of the like dangerous HTML elements, so they just render as strings. And another thing you do is, like I said before, escaping dynamic content. That would work also. So yeah, we have some exercises. I didn't want to keep this too long, so for the remainder of it, we're just gonna go over the first exercise. You can go to this link. It's sort of like a challenge. And after like, whatever, 10 minutes, 5 to 10 minutes, we're just gonna go over it. So yeah, try it out. Oh yeah, if you guys are experiencing an error, like make sure like a prereq it was like making an account. So make sure you're logged in, or else this isn't gonna work. All right, is anyone done? Is there? If not, we'll just do some more time. All right, so I'm gonna go over it. So like hack the site. It's a pretty fun site with a bunch of challenges that you could do pertaining to security. They always have like really weird examples, like Fisher's animal products. So I mean, first, if we want to tackle this, we want to find, our job is to find all the users, or like in their like email table. So like, I guess what we would do is like try to like figure out what actually like evaluates when we like enter into like a mailing list or something. So if we just enter like a empty value, we get this error, which is like a horrible error because you're basically like divulging the fact that you have a table called email, which is just like not good. You don't want to tell people that are potentially hacking your site that. So we know, okay, that's one thing we know, is that we have a table email. We could browse the other animal products. One is fur coats. So one thing you need to notice is that right here, you have a category, which, I don't know, it corresponds to like some sort of value in their table. And it seems to be like an integer. So like my first instinct would just be to put something that's like not an integer in there and how it reacts. So I'm just gonna put blah. And what's weird is like there's like no error that gets like, there's no error that's like handling this. So my guess is it still evaluates the query, even though it's not an integer. So that's good for us, because if it doesn't like validate the query, then we could potentially like inject some code in here, and inject some SQL into this URL. So that's what we're gonna do. What I could do right now is we're gonna use like the union keyword that we learned before. So yeah. Oh shit. Sorry. Oh, I can't do, can I? You just gotta trust me on this now. Yeah, let me, I'm going back here. Oh, those are a bunch of emails. Okay, can you see this? Well, yeah, okay. So inside this, we have a category. And so that's basically what I'm guessing is what terminates the statement, is an integer. So I actually want to combine the first statement and the second statement. So it not only includes whatever the first query statement actually gets us, but also includes the second query statement, which I'm trying to get everything in an email. So I'm going to do union. I'm going to do union all, which all is like another counterpart of union, which basically like disables all duplicate rows in it. So I'm gonna do select statement, and so now like what I said earlier is that union only works if you have like the same number of columns. So we don't really know how many columns the table that stores all the products like have. Like we don't know like these attributes. But after like a series of like guess and checks and like trial and error, I think you could see that there's like 3 components here. One's a picture, one's I guess like a description, and one's like a price. And another thing that we could assume is like a primary key identifier to distinguish one row from another. So it needs some sort of like ID, right? So this would usually take like a series of like trial and error to get like the columns right. But because we're like probably short on time, I'll just show you. So we're just gonna nullify all the columns that we don't really care about. And so since we're guessing that there's gonna be 4 columns, we need to project that in our next SQL statement. So we're gonna do null everything, null, null from email. And we're gonna try to inject that into our URL here. And then what we get is something like this. We inject it. It's been encoded into a URL format. So all the spaces turn into a %20, things like that. But then as you could see, in combination with the products, we also get everything, which happens just to be 1 column in email. And that's also listed with the products. Does that make sense? Yeah? Okay. Cool. I don't think so, because I think it should properly encode it here. So let me go back to it. Are we cool? Okay. I'm going to. So this is going to be our last exercise. Ooh. So our last exercise has to do with cross-site scripting. As a little hint, you're going to imagine that there's a domain called mrstealyourgirl.com. And there's going to be a script on there called Cookie Stealer. And you're going to actually try to steal users or an admin's cookies to impersonate them. And you could read the exercise description. You could see that developer hasn't been paid, and you need to impersonate an admin to actually pay that developer. It's really weird, but yeah, try your hand at that. Okay. So we're just gonna go over this. So in the instructions, we get an email and a password that are valid, but they aren't admins. They don't have administrative access. So the problem is this developer is pretty disgruntled, needs to get paid, and doesn't have admin access to, make the payment. So I think his password is "I love my work." So yeah, if we go into pay salaries, it says you are not an administrator, which is fine. After some snooping around, we notice a private message forum, and then we see M Crap, which is which is the owner. And so if you could see, I mean, if you inspect Element and take the time to look at it, you could see that this in this document, the message actually gets like evaluated. Like you could actually inject JavaScript into it. So if we actually like send a valid or a seemingly valid message to our owner is gonna read it from his HTML document, and his document is actually gonna evaluate that script. So what we're gonna do is we want to steal his cookie. So I'm just gonna put a title, and I'm gonna change the location to be the URL that I saved. And then I'm actually gonna go document cookie.cookie. So in this scenario, we're assuming that some authentication information is stored at document.cookie, and that we have some kind of a script to take that cookie from the query parameter and actually store it somewhere in some kind of like database server. Does that make sense? Okay. So if you actually send it, they kind of bail us out because there's not like another user. So they just like, if it's like a valid sort of like attack, then they give us sort of the information that's stored into the documented cookie. So what we're gonna do now is just like open up our console and actually just start storing these values in. And what we can do that is like, since cookie is basically like a string that acts like a key value store, we could just go to these and start storing them into cookie. I'm gonna make sure that so yeah, I stored that as string username, which is used as obviously your username. And if you actually check the application, and so now my username and my cookies is actually equal to my boss's username. So we're gonna keep on doing that for both our password and our int ID. And hopefully we could actually impersonate our boss. Where were the... Okay, int ID equals 2. Lastly. Okay, cool. Now that that's done, we check again. We see our int ID is equals to 1. This is equal to the string password that's given, that we got from our boss. And we're gonna refresh the page and actually go to pay salaries right now. And this is actually, we were granted access to this. So we can actually click pay and actually pay this man. So yeah, that's your gratification for that. That is gonna conclude this presentation. But thank you for coming. Yeah, that was it. I am going to email the non-truncated version of these slides with stuff about reverse engineering APIs and a little bit about session management. Also, a more comprehensive guide about encryption and like cryptography and sort of like some of those sorts of concepts. So yeah, you have that to look forward to. Thank you.
If any of you guys have a topic you'd like to speak about next quarter for a hack night, in the emails that we send, right? I think there's like at the bottom, there's like a link, a speaker interest form. So if any of you all want to, be Brandon basically for a night, that's pretty cool. I would like to be Brandon for a night. So you guys can, fill out that form. Thanks.